Hello, this is a presentation that was shown at the Public Information Meeting for New York City Department of Transportation's BQE from Atlantic Avenue to Sand Street project. Commissioner Polly Trottenberg, Deputy Commissioner Bob Collier, and myself, Tanvi Pandya, BQE Program Manager, presented the information at the Ingersoll Community Houses at 6 p.m. on September 27, 2018. We began by discussing the history of the BQE, which is a challenging project that was built by Robert Moses in the 1940s and 50s. Like a lot of the Moses structures, it was not built to last and is now showing signs of deterioration. The structure is complicated and includes many areas where the roadway is stacked or cantilevered, confined by other buildings and structures, and the Brooklyn Bridge and Manhattan Bridge. We are now facing the end of the structure's useful life and must either repair or replace the existing highway. This project spans 1.5 miles from off the BQE from Atlantic Avenue to Sand Street. As you can see in the pictures, the construction included the promenade being constructed at the same time that the BQE was built, and it is integral to the BQE structure. As some of you know, this project has been around for a few years. New York State DOT was working on this project up until 2011 when they suspended the environmental process. In 2014, New York City DOT added capital funds to its plan and began working on the project in earnest. We conducted a review of options with a panel of experts, as well as reviewed the possibility of a tunnel to replace the BQE corridor. There was also an origin and destination traffic study that tells us where the traffic is coming and going from in this corridor. In 2016, we completed an in-depth inspection of the whole corridor. This included creating access points within the structure to be able to do in-depth inspection from within the structure. What we found is that in 2026, the deterioration will have progressed to a point where trucks will need to be removed from the BQE. After that point, the deterioration would continue, and by 2036 to 2040, a complete removal of vehicles from the BQE corridor would be anticipated. So with the studies that were completed within the New York City DOT's efforts and the previous information available from New York State DOT, New York City DOT began work with a design consultant to develop some concepts. Now, these were done using some of the parameters that are part of the New York City DOT's constraints. 153,000 vehicles use this roadway, and that traffic capacity needs to be maintained throughout construction. Any congestion or slowdown in traffic has not only local street impact, but also regional transportation network impacts. We're also looking to generally build within the existing footprint, as there are other infrastructure as well as historic Brooklyn Heights and parks very close to the area. Given that this is a New York City project, we are operating under the constraints of the local control. For example, we cannot add tolls or congestion pricing under our authority. So while the larger conversation may continue and some of these assumptions may be questioned and reconsidered, the concepts being presented here are within the parameters that New York City DOT is operating with. Yeah. So first, let's start with the project corridor and look at how constrained the site is with Van Voorhis Park at the south end, Atlantic Avenue interchange that we are also looking to improve under this project. The yellow bands that you see on the video here are subway lines that go underneath the whole roadway across. On both sides, you see very tight quarters with buildings with 360 Furman as well as Brooklyn Bridge Park. At Montague, there is a TA facility on the other side, on the riverside. So there are multiple TA facilities both underneath, adjacent, and inside our structure. As we continue north, we go into very tight quarters under Columbia Heights. Columbia Heights itself is a bridge. It is also our pinch point for vertical clearance, as well as one of the structures that is in the poorest condition out of all the others. And it does have a park that sits on the bridge. As we continue beyond that, we go underneath Brooklyn Bridge, which is a very tight portal. There isn't a lot of room to work in this area, and the structure between Columbia Heights and Washington Street is also very complex. This is a double cantilever section that has a lot of varying structure types. And then we have a tight portal again under Manhattan Bridge. So as we were developing the concepts for rehabilitation or replacement, we had to keep all of these constraints in mind. And that is how we have, we want to make sure we find a solution that works for this whole corridor. As we've talked about in the past, the 2026 timeline is not that far into the future when you consider the size of the corridor that we're working against. The bottom two pictures are of the Geralman structure inside, and also on the visible side of the structure at the top of the deck, there are plates. So we are under a time constraint where we need to have addressed the BQE in this corridor. Otherwise, we will be at a point where we have to take trucks off the road, off the BQE, which would lead to traffic on local roads. Not surprisingly, BQE is one of the heaviest traveled roadways if you look at it in comparison, compared to some of the major projects that we are familiar with. Queensboro Bridge is probably the only other one in this area that has greater vehicles. The percentage of trucks in all of these is also quite high on the BQE. So this makes it quite complex on our staging concepts on how to maintain traffic as we move forward. On most projects, typically when you stage the traffic, there is a place alongside where one can place bypass traffic, or you can build on a parallel alignment. In this case here, we do not have space for parallel alignment. And what that means really is that when we are looking at the Staten Island bound and Queens bound traffic, it's not just a matter of detour this traffic completely away from the corridor, because when we did our origin and destination study, which is essentially a study of where is this traffic coming from and where is it headed, we find that 90% of the traffic has truck traffic is destined for one of the New York City boroughs. For the Staten Island bound traffic. In the Queens bound direction, that's 70% of the truck traffic. The number of vehicles that are coming in and out of Brooklyn that use this stretch is also quite high. So it is not a matter of sending traffic somewhere else, even if some of this traffic could be diverted to other roadways or other ways to get to areas that are to the north or the south. There's a significant amount of traffic that does need this corridor to get to various businesses and other points of connections to Manhattan. So when we talk about the traffic that is of the local neighborhood, if BQE didn't exist, that traffic would spill to all of the local streets and create a serious gridlock. This is a simulation we ran to see how traffic looks. So right now, the first slide shows the traffic as it exists right now, the red being the heavily used roadways that during the evening rush hours clog some of the streets in spite of there being a BQE that takes 3 lanes of traffic. If we were to eliminate that BQE connection in this area between Atlantic and Sands, all of that traffic would have to spill onto the local roadways. And as you can see, several more streets now are clogged and turned red. So this is a scenario we're trying to avoid and trying to maintain a parallel or a bypass roadway while we work on the main structure. There have been previous conversations around tunnels, and we have looked at it in a little more detail than what was previously considered under New York State DOT. If you wanted to look at the whole study, it is available on our website. But essentially, here are the main reasons why we don't think tunnel can solve the problem of this corridor. Number one, there is several subway lines that crisscross this area, so a tunnel would need to be aligned in such a way that it doesn't interfere with any of those tunnels. In addition to the subway tunnels, there are multiple large water tunnels that are part of DEP's infrastructure that also need to be avoided. After looking at all of those structures, there was only one alignment that would actually fit in this area. But what that does is completely bypass the downtown Brooklyn, including the connection points to Manhattan and Brooklyn Bridge. There's about 50% of the traffic on this corridor that either is coming or going to one of these bridges, Manhattan Bridge or Brooklyn Bridge. So a bypass tunnel would still require 50% of traffic to get through this area. And without BQE, they would have to use all the local streets to get around. So that is a major concern. So even with a bypass tunnel, we would still need to maintain this corridor in some form. In addition, tunnels are not only very expensive, they are also somewhat limited in what can be achieved in the current technology. The largest tunnel that we could build that has been successfully completed around the world, it has a diameter of about 54 feet, which only fits 2 lanes of traffic in each direction. Currently, BQE carries 3 lanes of traffic in each direction, and even then is over capacity. So the concept of dropping 1 lane in each direction and managing the traffic is not realistic. It would be very difficult to make all that traffic fit in the local road network. And one of the other things to keep in mind is that for a tunnel, you essentially have to also build a portal at each end. There's ventilation shafts, and there would need to be property seizures in order to create space for these portals and ventilation shafts. So there are some significant challenges with the concept of a tunnel. And while a bypass tunnel could be considered under another project, we're proceeding on this project with the understanding that no matter what, the BQE structure or the corridor needs to be maintained. The other concept that we had looked at is, could traffic go somewhere else? Is there another bypass that could be used? And one concept would have been the use of Belt Parkway during construction. However, Belt Parkway is a parkway, meaning it was meant for cars. There are several bridges not belonging to DOT. They are part of the transit authority's infrastructure that have low vertical clearance over the Belt Parkway. So that would be a significant undertaking to raise them high enough that trucks could use Belt Parkway, in addition to the narrow lanes and tight ramps and so on that would need to be modified to make them safe. This would be a huge undertaking and therefore is not considered an appropriate bypass for the corridor for construction purposes. So going back to what our structure is, in the triple cantilever section, there's multiple things that are of concern. There's limited access due to lack of shoulders. The lanes are narrow. There's vertical clearance issues as well as sight distance concerns with the tight curves, which lead to higher crash rates, up to 10 times higher than the statewide average. These are all concerns that we need to address. In addition to that, there have been vibration complaints from several buildings that adjoin the structure because what holds the roadway up also holds up the slope of Brooklyn Heights. And what holds up the BQE roadways also holds up the promenade itself. So this is one combined structure and needs to be addressed accordingly. We cannot deal with one direction roadway without addressing the entire structural integrity. And while we were thinking about what to do in this corridor, we're taking the opportunity to see what are the greater benefits we can achieve. So there are some concepts that have already been discussed, such as unifying Van Voorhis Park and creating a safer Atlantic Avenue interchange while we're in the process of working through this area. We have also been approached by some community members to have a direct connection from the promenade down to Brooklyn Bridge Park as an additional connection point. We have the opportunity to separate the BQE structure from the Brooklyn Heights community and eliminate the vibration concerns. But the biggest opportunity we have is at the north end, where Manhattan Bridge and Brooklyn Bridge currently have their traffic come down to the local street network and then make their way to the highway system. If we can make a direct connection from Brooklyn Bridge to the BQE and similarly at Manhattan Bridge, that would relieve significant congestion from the local street and improve the pedestrian and bike access. And these are some of the goals that we are looking to consider as we develop this strategy for this project. Fortunately, with all of your support, we have been able to get the design build authority for this project. And while that will be very helpful in ensuring this project moves forward in the most innovative way, we have to work towards creating that environment of innovation. Our environmental process needs to be structured in a way that it leaves room for the design build community to come in with innovations. If we limit the area in which a design builder can work or build very tightly, it doesn't allow them to think creatively and come up with better ways or faster ways of doing things. So one of the thoughts that we have to keep in mind as we move forward is how do we leave room for innovation that we can get out of harnessing all of the design build teams that will be competing to win this project. And one other thing to keep in mind is as we move forward, there will be times where it will seem that we are coming out quite a few times with little bits of information, and that is the nature of design build. It's a little more iterative. There will be many more conversations with all of you, and we will keep you informed as we move forward in this process. So one of the main things about this design build and why it was critical to this project is because the way we build in this area is going to be directly tied to what we end up with at the end when the construction is over. And this is very important to understand because there are ways to construct that limit the type of structure we will be left with. So we started out with a traditional approach. What is typically done, and you might have seen it around the city, is you do one lane bypass, do a reconstruction of a lane, and then you keep shifting until you've replaced the entire structure. And we found this approach to be slow for this corridor, and we also felt that there was some concern with the time and cost related to this structure, to this method. And so we looked for another way. And the other way we've looked at is what we're calling the innovative approach, temporary elevated roadway. This video is an extended version of the BQE replacement at the triple cantilevers portion using the incremental method of replacement. A shorter version was used in the September 27th meeting due to time constraints. The work would begin with construction of new foundations along Furman Street in the sidewalk area. Once that is completed, new foundations would also be placed along Furman Street along the existing BQE wall, and traffic would be shifted over in the first lane that's configured at that Staten Island level roadway. During the overnight hours, progressive demolition and construction would continue at the Staten Island bound roadway level. This requires modification of existing structure, which is a very slow process and could potentially lengthen the duration of this phase depending on condition of the existing structure. Once that is completed, an upper level roadway would be built, and then the Queens-bound traffic can be shifted over to this new bi-level structure that is built along Furman Street. This condition would exist between Joralemon and just before Columbia Heights. At that point, the existing promenade would be removed, and a sheeting would be placed behind the existing wall, which allows removal of portions of the existing retaining wall along Brooklyn Heights for placement of foundation elements for the new BQE structure. At that point, the soil and the trees behind the retaining wall can be removed so that the existing BQE structure can be removed and replaced. This requires work to retain the existing soil by using soil nailing method. This is just one concept that's been considered. And then the new foundations could be built for the new BQE structure. Once the foundations and the retaining wall effort is completed, then the existing bi-level structure can be extended out to the west, to the east, and roadway can be extended and the retaining wall replaced along with the promenade. Under this setup, the promenade could be out of availability for up to 2 years. At that point, the traffic can then shift back to the east as the upper level is completed, and then modifications to the existing structure would be made. Traffic would shift to its permanent location, and the columns would remain in position for the rest of the structure's life. So the incremental approach does allow us to get to the roadway width that we need. We can get to most of the widened lanes and other safety improvements that we're looking for. We would be able to eliminate the vibration concerns that we have, and also would eventually replace the promenade by doing some rolling closure. So we would replace portions of promenade until all of the promenade was replaced. But it makes the connections to Brooklyn Bridge and Manhattan Bridge a little more difficult because it requires additional complete weekend closures to make sure that those connections can be completed. The thing with this method of construction is that it creates what we call cattle chutes. Essentially, when you have a concrete barrier on either side and the travel lane is between these kinds of lanes that are snaking across a long corridor, it tends to slow the traffic down. It makes people a little bit nervous, particularly if there are lane splits and they have to make a decision on which direction to or which lane to be in. Everybody's afraid of missing an exit or something. And so that leads to overall queuing. Essentially, you don't get as much traffic through that corridor as we normally do, which leads to backups at the two ends of the corridor. We did, according to some of the numbers we have run, that could lead to up to 12,000 vehicles per day that can't get through. That could add up to 3 miles of impact in either direction. So the concern with this type of construction is on a few fronts. One is the cost and on-time completion is a lot less certain. Vertical clearance improvements are a little bit more difficult because the tight quarters that we're in, we are tying to the existing structure, so it essentially ties us to a certain elevation. It requires several complete weekend closures, and by weekend closures, we mean Friday night into Monday morning. So that is a significant complete closure of both directions of BQE. There's also a much greater construction activity during the overnight hours, which has its own noise issues. And also the duration is longer, so the queues and the traffic issues last much longer. One of the things to keep in mind, which you can see in the top picture, is the work being done on the existing structure in order to be able to get to this final condition that's shown in the lower picture. This is work being done on the existing structure every night during the few hours where there is complete two-lane closure available to us. Should anything go wrong with any of that work, because we're working with an existing structure, this could result in delays in reopening the lanes in the morning, and that would be a significant issue because that could lead very quickly to a 12-mile impact in either direction. And that is something to keep in mind when you're doing construction of this nature. This is similar to doing rehab work at home. If you open up a wall and suddenly find a surprise behind it, it has a big impact on the cost and the schedule of what comes next. So this is something that is of concern to us with this type of construction. Also, as you would have noticed, that the line of columns stay along Furman Street all the way down to Atlantic, meaning they are in the sidewalk in front of 360, and that's a permanent condition. So then what is the option? If you can't go to the left, you can't go to the right, you can't go down, then the only place to go is up. And this is where we come up with this elevated roadway concept. So this is a fly-through of what that could look like. So just past Congress Street, we would start off with starting to build this bypass that is going towards the west to the degree possible so that we can open up the space for the existing roadway to be replaced. So this would be a complete bypass where all the existing traffic can be shifted over. It's rising up from that elevation to rise to the promenade level so that once the traffic is shifted over, we can build underneath it. There are sound barriers that we would obviously be installing alongside the residential areas. There are also viewing platforms that could be installed at each of the cross streets to allow for some space for people who want to visit and see the view. And then the construction is occurring underneath this roadway, which gives much more availability for the contractor to stage, to do the demolition, and most of the work can be done during the daylight hours, which is much more productive and reduces the construction duration. The promenade continues through the Columbia Heights Bridge area, which essentially is a replacement of the Columbia Heights Bridge, which then, beyond Columbia Heights, it would bypass the existing roadway again and go over the approach to Brooklyn Bridge. This allows us to build between Atlantic and Washington in one continuous stage, which is much more productive, gives us much more room to modify the alignment both vertically and horizontally, and limits the number of weekend closures to 2 or less. What this looks like in terms of at triple cantilever in a cross section, to kind of break down how this construction would occur. Again, the construction would start at Furman Street. So along the center of Furman Street, there would be a row of columns installed. And because this is brand new construction, we can have the aesthetics that we would like to see. Here we've used arch as just an option. But once those supports are built, during overnight hours, when we're able to have one lane in each direction, traffic would be shifted to the lower level, and the promenade would be removed at the upper level during those overnight hours. Once that is completed, a row of sheeting would be placed behind the existing wall so that the support structure along the east side of the elevated roadway can be placed. Once that is placed, then we can build the superstructure, which is essentially the promenade being built ahead of time, which would be used and set up as a roadway for this phase. Once that is ready, the traffic then shifts to that upper level, and then construction can begin at the existing BQE level. Again, because this whole structure is completely separate from the existing BQE, there is much greater freedom on how to replace the structure. Here we're showing how the existing structure would be removed, and we're considering using soil nails to replace the supporting structure. And during the daytime hours, this construction could be done in a much more expedited manner. We can also put in some incentives for this work to be completed faster. And then once they've replaced that structure, they can go back and replace the green area behind the existing promenade and replace the vegetation that was disturbed in the removal of the promenade. So once that is completed, the roadway, the traffic then moves back down to more or less the existing elevation, and the upper level that was used as a roadway is reconfigured to become a promenade. We have an opportunity to make it a wider promenade. It can be configured in various ways depending on input from community and the vision that we set for ourselves. So this is the concept of how the elevated roadway would be completed. This video is an extended version of the Columbia Heights staging concept under the elevated roadway. The entirety of it could not be included in the presentation on September 27th due to time constraints. The work would begin with modification of the Squibb Park as well as demolition of the Harry Chapin Playground. Construction would begin of the west abutment behind the existing abutment, with the roadway at Columbia Heights closed to traffic. During overnight hours, when traffic can be maintained as one lane in each direction on the lower roadway, the existing superstructure of Columbia Heights would be removed. During the daytime, BQE traffic would revert to its regular traffic pattern. Once the new abutment has been completed, during the overnight hours again, when traffic is shifted to the upper level, the existing abutment on the west side of the structure would be removed. This allows for a widening of the BQE at the lower level. Again, with traffic being diverted to the lower level, replacement of the eastern abutment would begin. This would be completed during the overnight hours over a period of time, and along the same time that the rest of the elevated roadway is being built, the Columbia Heights Bridge would be replaced, and as a continuation of the elevated roadway would be used for traffic during the rest of the phases, which would include replacement of the BQE at Queens-bound as well as Staten Island-bound level for the entire corridor. This would include replacement of the on-grade work at the Staten Island-bound roadway with the widening that is necessary to meet the lane widths, as well as replacement of the Queens-bound structure with the wider roadway with the shoulder as well as 12-foot lanes. Once the traffic is shifted down to this level on the new BQE, the level above would revert to the Columbia Heights as it is currently, with the park being replaced, as well as an additional open space that could potentially be left in place at Columbia Heights, where it connects into the Brooklyn Promenade currently. So the concept with the elevated roadway is it gives us much greater freedom to improve the geometry both vertically and horizontally. We can completely separate the BQE from the Brooklyn Heights neighborhood. We can also get a wider promenade at the end if desired. We have much greater opportunity for better aesthetics of the completed structure. But also the thing that is especially attractive about this is that it allows the direct connections to Brooklyn Bridge and Manhattan Bridge to be completed without additional extensive closures. So this would be a significant improvement for the local streets. The elevated roadway provides numerous benefits during construction. It reduces the construction duration in comparison to the traditional. It's down to 6 years. It has much greater certainty of project cost and on-time completion for multiple reasons. One of them being that we have much more flexibility in the construction staging sequence, since the contractor has the full daytime hours and the traffic is not being moved around constantly. We can push the contractor to finish on time and provide incentives to get certain specific things done, such as reopening the promenade at the earliest, and such things that would be of benefit to the community. It also causes the least amount of impact to the traffic. Once the traffic is shifted to the upper level, it continues in the same configuration for the rest of the construction. It does have some dramatic impact at the Brooklyn Heights area along the promenade. It does need trees to be removed, but this is similar for the traditional. We need to replace the wall that separates the Brooklyn Heights from the BQE, which causes the trees to be impacted, but we are fully committed to restoration of the green space at the end of the project. So here we are showing you what a Brooklyn Bridge direct connection would look like. Currently, when someone exits off Brooklyn Bridge down to Fulton, then there's a couple of left turns. You sit through a couple of light cycles because there's always a backup at those lights. There's two lanes turning left before you can get onto Wine Street ramp. Under this concept, we could make a flyover over Brooklyn Bridge approach over the BQE and then connect back into BQE Staten Island bound just before it ducks under the Brooklyn Bridge. This would reduce the number of vehicles that are in the local street and also allow us to close York Street ramp because by redoing Manhattan Bridge ramp connections, there are some redundant ramps that we can eliminate and create more open space. This would significantly improve the traffic on Old Fulton and the pedestrian access to Brooklyn Bridge Park in that area. At Manhattan Bridge, again, currently traffic exiting off Manhattan Bridge goes to J and Sands and then makes a couple of turns to get onto BQE. Under this concept, we would be building a direct connection onto over the Manhattan Bridge approach and then connecting into both Staten Island and Queens-bound direction with a flyover ramp. This will allow us to reconfigure the existing ramps in a way that will open up some of the green space that's locked between some of these ramps and also eliminate a lot of the truck traffic that's in this neighborhood. And so that is a significant benefit we can achieve by making these direct connections. So looking at the two concepts side by side, one of the things to be noted is that the elevated roadway can be completed in 6 years, and we have much more certainty of getting this done within the 6 years because of the certainty we have with a contractor being able to work during daytime hours versus with the incremental method where it could be 8 years or more because of the work that we have to do on the existing structure and the work being done during the overnight hours for a significant portion. So if something comes up that is not anticipated, it could complicate not only the completion, but the schedule and the cost go with it. So there's some significant challenges with the incremental method of construction. Promenade and Columbia Heights both need to be replaced, so there would be some time that both of those need to be closed. So under either circumstances, there is a duration where both of those areas would be closed. But the big other thing to keep in mind is the direct connections to the Brooklyn Bridge and Manhattan Bridge can be completed without any additional weekend closures. And also the traffic impact is during the overnight hours for a shorter duration with the elevated roadway, whereas the incremental method will have major traffic impacts causing spillover into the local streets for a much longer duration and would be much more difficult to control given the uncertainty of working on existing structure. So with the idea of re-envisioning the BQE, we're looking at unified Van Boris Park with improved Atlantic Avenue corridor, better opportunity to make a direct connection down to the Brooklyn Bridge Park from the promenade under the elevated roadway, as well as better opportunity to make direct connections to Manhattan and Brooklyn Bridge, complete separation of the BQE structure from Brooklyn Heights so that we can eliminate the vibration issues and overall improve the safety and operation of the whole corridor. As we continue through this was only the first time that we have discussed this detailed staging concepts with the community. There will be many more conversations ahead, including the formal process that is required under the NEPA. We will be kicking off the NEPA process in the near future, and we will be back in touch with you about that. There will be workshops where we can focus on specific areas of interest, such as parks and playgrounds or the pedestrian bike safety concerns. So there will be many more times that we will be in touch. Over the next couple of years, we'll be completing the environmental process as well as getting the design build team on board and proceeding with the procurement for that effort. So we thank you for taking the time to hear about our project, and we request that you stay in touch with our website. We will be putting out any invitations to the upcoming events or new information as it becomes public on the website. You can also send us email via this website or get in touch with someone on the staff for any particular concerns that you may have. So www.bqe-i278.com is our website. Please visit and stay in touch. Thank you.